Okay. Hello, good day everyone. Last time we discussed on the uses and importance of number systems. And now I'm going to discuss on the techniques on number systems conversion. For this discussion, we'll be going to focus on the four numbering systems. We have the decimal, binary, octal, and hexadecimal. First is we have the decimal, which is also known as the base 10. So tinawag siyang base 10, it's because each digit can only contain from 0 to 9. So that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So say for example, we have 1, 4, 5 base 10, 1, 2, 9 base 10. So basically, pag magbigay ka ng number, you have to indicate kung anong klaseng number system siya. So in this case, since decimal number siya, so you have to put a subscript on each number para ma-identify natin siya na decimal. Okay. So next is we have the binary, or also known as base 2. So meaning each digit can only contain 0 and 1. So we have here an example, 101001 base 2. Then the next number system, we have the octal, or also known as the base 8. So each digit can contain 0, 1, 2, 3, 4, 5, 6, and 7. So say for example, we have 145 base 8 and 107 base 8. So as you can observe, ang octal, we have 145 can also be a decimal number 145. So to let us not be confused with these two numbers and to identify kung anong number system siya, so that is why it's very important to indicate kung anong number system siya. So you have to indicate whether it is base 10 or decimal, or base 8 or octal, or even binary. And then the last number system that we're going to discuss is the hexadecimal, or also known as the base 16. So tinawag siya na base 16 from the word itself. We have the hexa, which is 6, then deci, which is 10. So i-add natin yan, so we have 16. So kaya siya base 16. So each digit can be represented by 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So ang next corresponding digit niya is actually 10. So kaya lang yung 10 is dalawang digit siya, so you have to represent that to a letter, which is letter A. Then 11 is B, C is 12, 13 is D, 14 is E, at saka yung 15 naman is F. So we have here an example, 2A4 base 16. So take note to always indicate kung anong klaseng number system siya. So it's very easy for us to identify kung hexadecimal kasi may letter. But how about the other number? Right? So yun nga, example is 145. Kung wala siyang base, so we can identify this as an octal also. So para hindi tayo ma-confuse, kaya lagyan natin siya ng base number. So sa numbering system, we can actually create our own number system. So pwede siyang base anong wala dito, base 9. You can also create a number system that is base 11, base 12. So depende kung anong number system ang gusto niyo i-create. But since sa computer architecture and computer system, itong apat na to na common number system ang ginagamit, so that is why we will be focusing on this. And as we all know, each of these number system also has a contribution on the computer system. Okay, so yun nga. So since dapat isa lang na digit ang pwede ma-represent in each position, so yung 10 sa hexadecimal is ni-represent natin siya ng A, and so on. Okay, so ano ba yung mga characteristics of numbering system? So first is the digits are consecutive. So meaning sunod-sunod siya. So ayun nga, sa decimal number we have from 0, 1, 2, 3, 4, sunod-sunod siya. And then that is also true to all number system. magkasunod-sunod rin dapat. Number 2, the number of digits is equal to the size of the base. So, ibig sabihin, yung mga digits in each position, so say for example sa decimal, so we can represent that as this. So, this is a number. We can consider this as a decimal number. Kasi pasok siya doon sa number of digits doon sa base 10. So, how about, but another question, can we represent this as an octal number? Pwede ba siyang octal? Hindi pwede. Kasi wala namang 9 at wala namang 8 doon sa octal number system. It's because sa octal number is from 0 to 7 lang siya. Okay, so another. 0 is always the first digit. Ayun. So, as you can observe doon sa numbering system, all of those number systems are nag-start siya ng 0. Number 4. The base number is never a digit. So, ano bang ibig sabihin nito? So, let's go back here. So, ang base 10, wala siya dito sa mga numbers na pwede nating ma-represent dito sa decimal. Sa binary naman, base 2 siya, wala din siya dito. As well as sa octal, base 8, hindi din siya nabilong dito. Sa, of course, sa hexadecimal, hanggang 15 lang siya. Okay, then when 1 is added to the largest digit, a sum of 0 and a carry of 1 results. So, say for example, sa decimal number, pag meron tayong 9, then pag mag-add tayo ng 1, that is equals to 0, carry 1, bring down natin, kaya nagiging 1, 0 siya, which is number 10. But in binary form, this is another iba na yung value nito. Ayan, so that is why we have to indicate its base. Okay, the numeric values are determined by the implicit positional values of the digits. So depende siya. So for example, this one, 1, 0. So that is 10 or 0 times 10 to the power of 0. Ito naman, 1 times 10 to the power of 1. So, ibig sabihin, 1 times 10 to the power of 1, that is 10. Then, this one, 0 times 10 to the power of 0, that is 0 times 1. Or, i-add natin yan dyan. So, of course, any number multiplied by 0 is 0. So, ayan, that is equals to 10 also. So, that is true to all the number systems. Okay. So, we have the significant digits. So, meron tayong tinatawag na least significant digit and most significant digits. So, ang least significant digits, ito yung sa rightmost part. Okay? At tapos, sa most significant digits naman, ito yung nasa leftmost part. So, another, we have hexadecimal. Ano dito ang least significant? Of course, ang A. Tapos, ang most significant is 1. Okay. Decimal number system, or also known as our default number system. So, base 10 siya. So, it is a positional system where the rightmost digit is the ones position. The next digit to the left is the tenths position. Then, ang next naman is hundreds and so on. So, the value that the digit represent depends on the weight or position they hold. The weight are based on the power of 10. So, ayan. So, meron tayong ones, tens, hundreds, thousands, 10,000. Tapos, ang next niyan is ang 100,000 and so on. So, yun yung mga tinatawag natin na weight. So, in a number system, depende siya kung anong base number. So, in this case, sa decimal, that is 10. No? 10. How about sa binary? So, we can have a weight of 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, we have 2 to the power of 3, we have 2 to the power of 4. So, that is, of course, 2 to the power of 0, or any number raised to the power of 0 that is always equals to 1. No? So 2 to the power of 1 is 2. This is 4 to the power of 2. 2 to the power of 3 is 8. 2 to the power of 4 is 16. So as you can observe, dito sa binary, 1, 2, 4, 8, 16. Sa decimal, that is 1, 10, 100, 1,000, at saka 10,000. So we can also, ang ibang number system din is positional system din siya. So you just have to change kung anong klaseng number or base number meron ang corresponding na number system. Okay, decimal positional notation. So yun nga, so we have here an example, 6219. Itong 9 is plus 2, 9. Tapos, ang 1 is 1 times 10. 2 times 100, 200. 6 times 1,000, 6,000. So kung i-add natin yan siya, that is equals to 6,219. Okay, so it is the decimal number system. Now, let's move forward with the number system conversion techniques. So we have 4 number systems na i-convert natin with each other. So i-convert natin siya, ang decimal, to any of these number systems, as well as the other number systems. Convert din natin siya with the other number systems. So basically, meron tayong 12 conversions. Okay? 12 lahat na conversions. So first rule for the number system conversion or technique, first technique, decimal to any number system conversion. So kung mag-convert ka ng this from decimal to any of these number conversion like binary, hexadecimal, or octal, pag i-convert mo yung decimal, we will be using division algorithm. So ano ba yung division algorithm? So in this algorithm, you just have to divide the number with the base of that number in which you want to convert. So say for example, if you want to convert the decimal to binary, so divide natin siya by 2. So if you want to convert decimal to octal, so ano yung base niya? So divide natin siya by 8. So ang decimal to hexadecimal, i-divide natin ang decimal by 16. So ganun lang yun ka simply ang division algorithm. So let us have an example. So let us convert 67 base 10 to its binary equivalent. So since binary, i-convert natin ang decimal to binary, so we're going to divide the decimal to 2. So ayun, so step 1, 67 divided by 2, that is 33. So of course, meron siyang remainder na 1. So i-separate mo yung remainder, ilagay mo siya dito sa right side. Okay, then record the quotient in the next row. So ang quotient natin dito is 33. So i-divide na naman natin yung 33 by 2. Ayun, so we have 16. Of course, meron pa rin siyang remainder na 1. So do the same process. So we have 16 over 2. Of course, that is 8. Remainder 0. Then repeat again, 8 divided by 2, that is 4, remainder 0. Then 4 divided by 2, that is 2, remainder 0. Then of course we have 2 divided by 2, that is 1, remainder 0. Still, do the same process. 1 divided by 2, ang magiging result niya is 0.5, right? So in this case, since mas maliit na yung numerator kaysa sa denominator, all you just have to do is to carry the previous quotient as the remainders. Okay, then stop. Ayun. So with the result, we can actually say that it is 1 0 0 0 0 1 1 1. So itong first remainder natin sa step 1, ito yung least significant bit. Okay, LSB. Tapos yung last remainder, ito naman yung MSB or most significant bit. Okay, so we have here another example, decimal to octal. So convert 150 base 10 to its octal equivalent. So in this case, divide natin siya by 8. So 150, so this would be 150. So 150 to siya, hindi siya 149. So 150 divide by 8, so that is 18, remainder 6. Now, ang quotient natin is 18, divide naman natin siya by 8, that is 2, remainder 2. So since mas maliit na yung numerator, so carry over na lang siya yung 2 as our last remainder. Then stop the quotient since 0 na yung quotient. So our final result is 2 to 6. Okay, same pa rin, LSB pa rin yung first remainder, MSB the last remainder. Okay, now convert 830 decimal to hexadecimal. So same technique. So pag convert mo yung decimal to hexadecimal, divide mo yung decimal by 16. Ayun, so we have here 830 divided by 16, that is 51. So ang remainder natin is 14. So take note, sa hexadecimal ang 14 is equivalent to letter E. Okay, do the same process. So 51 divided by 16, so that is 3. Ang remainder din niya is 3. Now yung 3, pag divide mo siya by 16, that is 0. So automatic na yung quotient mo ng previous will be your remainder. Okay, then our result is, of course, 3E. Same pa rin ha. Yung LSB natin is yung first remainder. MSB is our last remainder. So that's how so yan yung process on how to convert from decimal to any other number system. Okay, so for your learning activity number 2, you have to convert these numbers to its corresponding number system. So for number 1, 1785 base 10, convert mo siya to its hexadecimal equivalent. So number 2, 709 base 10, convert mo siya to its octal equivalent. Tapos na number 3, 53 base 10, convert mo siya to its binary equivalent. Okay, now so we have rule number 2. So in reverse order naman siya. So kanina we convert decimal to any other number system. Now from binary, octal, and hexadecimal number system, convert natin siya to decimal. So ano yung gagamitin natin? We will be using the multiplication algorithm. So yun nga, sa mathematics, as we can remember, the reverse operation of division is multiplication and vice versa. So since reverse ang gagawin natin ngayon, so we will be using multiplication algorithm. So ano ba yung sa multiplication algorithm? So you just have to multiply the digits by their starting from the right. Multiply the digits by their base, no? By their weights. This is by their weights starting from the right. Then to find the decimal number equivalent, sum those products. So we have here binary to decimal. So i-convert natin to 10101101 base 2 to its decimal equivalent. So you have to identify first its weight and then multiply it by its digit. So first we have here 1, tapos 0 1 0 1 1 0 1. So ano ba yung position ng rightmost? That is position 0. Next we have position 1, position 2, position 3, position 4, position 5, then we have position 6, tsaka position 7. So, ang pinaka last digit or most significant bit is nasa position 7. So, in this conversion from decimal to binary, so, multiply natin ang digit. So, 1 times 2 raised to the power of each position, which is 7. Then, plus naman natin 0 times 2 to the power of each position, which is 6, plus 1 times 2 to the power of 5, plus 0 times 2 to the power of 4, and so on. So we have here, so we have 1 times 2 to the power of 7, that is 128, plus ito, 0 times 2 to the power of 6, of course that is 0. Always remember that any number multiplied by 0 is equals to 0. So 1 times 2 to the power of 5, that is 32. Okay, we have plus 0, plus 8, plus 4, plus 0, then plus 1. So dito, 1 times 2 to the power of 0, of course 1 siya. So any number naman raised to the power of 0, that is equals to 1. So of course we have 173 base 10. So yan yung sa binary to decimal. How about from octal to decimal? So same process pa rin, but we have to multiply it by the weight of the octal in each positions. So in this case, we have 3, 2, and saka 6. Ang position ng 6 is 0, position ng 2 is 1, position naman ng 3 is 3. So that is why ang 3 multiplied natin siya by 8. So itong 8, saan to? Ito yung base naman ng octal. Okay? Raised to the power of its position. So ano yung position ng 3? It is 2 pala. Rather, sorry. So this is 0, 1, 2. So 3 times 8 to the power of 2 plus 2 times 8 to the power of 1 plus 6 times 8 to the power of 0. So that is 0, 1, 2. Okay. Then we have here 3 times 64 plus 2 times 8 plus 6 times 1. So that is equals to 192 plus 16 plus 6 or 214 base 10. Okay, next conversion is from hexadecimal to decimal. So in this example, we have to convert 1AF5 base 16 to its decimal equivalent. So same process pa din. Okay, but by this time, we'll be using the base 16. So before that, itong 5 is position 0, F is position 1, A is 2, tapos ang 1 is 3. So of course, we are going to multiply 1 times 16 raised to the power of 3 plus A. So ang A is 10. Okay, this is A, ang 10. So of course, 10 times 16 to the power of 2 plus ang F naman is 15. So that is why 15 times 16 to the power of 1 plus 5 times 16 to the power of 0, which is 1 times 4, 0, 96 plus 10 times 2, 5, 6, and so on. So ang sum niya is equals to 6901 base 10. So don't forget to put base 10 to identify that it is a decimal number. Okay, so for your learning activity number 3, still number system conversion, you have to show solution for this. So we have to convert 10110 base 2 to its decimal equivalent, number 2. 702 base 8 to its decimal equivalent also. Number 3 is 1E04 base 16, convert it to its decimal equivalent. Okay, so rule number 3, number system to another number system conversion. So binary, octal, and hexadecimal. So we will be converting this to each other. So in this method, we will be using 3-bit and 4-bit substitution code. Okay. So sa 3-bit substitution code, that is octal to binary and binary to octal. Gagamitin naman natin ang 4-bit substitution code if we're going to convert hexadecimal to binary and binary to hexadecimal. Okay. So, gagamitin muna natin ang 3-bit substitution code. So, converting octal to binary and binary to octal. So, ano ba yung 3-bit substitution code? So, with this table, ito yung gagamitin natin. Okay. So, sa decimal 0, ang 3-bit binary equivalent niya is 000. Ang 1 naman is 001. Ang 2 is 010. 3 is 011. 4 is 100. 5 is 101. 6 is 110. Ang 7 is 111. So, all I just did here was to convert the decimal number to its binary number. But we are using the 3-bit. So, say for example, 7 divided by 2. So, that is, of course, 3, remainder 1. Tapos, 3 divided by 2. That is, of course, 1, remainder 1. Tapos, 1 over 2. That is 0, remainder 1. So, mag-stop na tayo. So, that is why 111 ang 7. So, that's how it is. Okay, so let us convert 216 base 8 to its binary equivalent. So, convert natin from octal to binary. So, we will be using 3-bit substitution code. Okay, so always remember that in this method, we will be using this table. Okay. So, using the 3-bit substitution code, ang 2 ay equivalent niya is 010. Ang 1 naman is 001. Ang 6 is 110. So, i-merge mo lang yan siya. So, we will have 010, 001, 110. Of course. So, in this number, any number, basta mayroon siyang 0 sa left side, pwede natin siyang i-crash out. Okay? So, it would not change its value. Ganun pa rin siya. So, that is actually similar with, for example, meron kang 500 pesos. Nakay 500 pesos. So, if you're going to add 0 dito sa leftmost part of your number, it is still 500. It would not change its value. Pero, pag mag-add ka dito sa rightmost part, magiging 5,000 na siya. So, that would change its value, 5,000 from 500. So, that is why, kahit marami kang 0 doon sa leftmost part, hindi pa rin siya mag-change ng value, no? So, we can actually crash this out. Okay? Okay, now, we have binary to octal. So, convert natin ang 1010100 1111 base 2 to its octal equivalent. Okay? So, still using the 3-bit substitution code. But by this time, i-group muna natin yung binary number by 3 bits from the right. So, starting from here, from the right. And then, convert natin siya to 3-bit substitution code. So, meaning, this is one group, another group, another group, and then another group. So, since kulang siya ng isang digit, so, mag-provide tayo ng another 0. So, yan nga, this would not change its value. So, lagyan lang natin siya ng 0 para mahanap natin kung anong decimal equivalent niya doon sa 3-bit substitution code. So, still using the 3-bit substitution code, this is equals to 2517. And, merge natin yan siya. That would be our final result, 2517 by base 8. Okay, so for your learning activity number 4, convert lang natin ang corresponding number. Show solution pa rin. So 3072 base 8, convert natin siya to its binary equivalent. And number 2, we have 1101 000110 base 2, convert natin siya to its octal equivalent. Okay, now let's move to another technique using 4-bit substitution code. So we will be converting hexadecimal to binary, binary to hexadecimal. So same with the 3-bit binary, meron tayong table, no? But by this time, we are using the 4-bit binary codes. So we have here corresponding hexadecimal from 0 to F. So meron din siyang 4-bit binary equivalent. So from 0, that is 0000, so on. So until we have F or 15, that is 1111. So kung i-convert mo ang 15 to binary, ang magiging result niya is 1111. Okay. So now let's convert hexadecimal to binary. Convert natin ang BA9E to its binary equivalent. Okay, so we will be using 4-bit substitution code. So based dito sa doon sa table, ang B, or this is 11, A is 10, 9, we have E is 14, right? So using 4-bit substitution code, ang B is 1011, A is 1010, ang 9 naman is 0101, ang E is 1110. So merge lang natin yan. So that would be now our final converted number, the binary equivalent of our hexadecimal number. So don't forget to put the base, no, para ma-identify natin kung anong klaseng number system siya. Okay, we have binary to hexadecimal. So convert natin ang binary number 1010100111 to its hexadecimal equivalent. Okay, so we have here, so ang gagawin natin dito is that we're going to group the binary number by 4 bits from the right. So kung kanina 3 bits, ngayon 4 bits. Okay, before natin siya convert using 4-bit substitution code. So meaning this is one group, another group, and another group. So pag mayroon siyang missing digits, kulang siya, so lagyan mo lang siya ng 0. So that would be 54F. So merge lang natin yan. So that will be our final result. Okay. So take note that you can actually create another way of converting binary to hexadecimal, or yung mga previous na conversion. Like binary to decimal, tapos decimal to hexadecimal. But it would take a lot of time and effort to do it, but you still arrive with the same result. So why use it kung meron namang shortcut na process? Alright, so ito na lang yung technique na gagamitin natin, binary to hexadecimal using the 4-bit substitution code. Okay, so for your learning activity number 5, you are going to convert this. So number 1, 8A0F to base 16, convert mo siya to its binary equivalent. And then this binary number to its hexadecimal equivalent. And now we have from octal to hexadecimal and hexadecimal to octal. So with this conversion, gagamit tayo ng 3-bit and 4-bit substitution code with each conversions. Okay, so sa 11, octal to hexadecimal, no, convert natin tong octal number 3765 to its hexadecimal equivalent. So ang first natin gagawin class is to convert this octal number using 3-bit substitution code. So, ang mangyayari niyan, ang 3 that is 0117 naman is 111, 6 is 110, ang 5 is 101. So, ang next natin gawin is gamit tayo ng 4-bit substitution code. But before we can use the 4-bit substitution code, so i-group natin siya by 4. So, that is one group, that is another group, and that is another group. And then, using sa 4-bit substitution code, let's try to identify kung ano yung equivalent niya. So, ayun. So, ang first group from the right is 5. We have F at saka 7. Then, merge mo lang yan siya. Then, that would be our final result. So, this 3765 base 8, ang hexadecimal equivalent niya is 7F5 base 16. Now, from hexadecimal to octal. So, convert natin ang A04F base 16 to its octal equivalent. So, ang first natin gawin is convert natin siya using 4-bit substitution code. So, kung kanina, ang first nating ginamit is 3-bit. Now, from hexadecimal to octal, we are going to use 4-bit substitution code first. So, ang equivalent niya is this. So, ang A is 1010, ang 0 naman is 0000, ang 4 is 0100, ang F is of course 1111. Then, using 3-bit substitution code, of course, group muna natin siya by ito 3, no? Ayun. So, by 3, group natin yan. Ayun. So, meron tayong missing digits. So, lagyan natin ng 2 0. Then, convert. So, that would become 120117. Then, merge lang natin yan. That will be our final output. So, 120117 base 8. So, for your learning activity number 6, convert nyo lang ang corresponding numbers. So, number 1, 6A C3 base 16, convert mo siya to its octal equivalent. And then, so number 2 is 5617 base 8, convert mo rin siya to its hexadecimal equivalent. So, that's all for the conversions, no? Mga techniques na gagamitin natin when you are going to convert one number system to another number system. So, as a summary, to help you recognize kung paano yung mga gagamitin natin na mga algorithms and methods. So, if you are converting from any decimal number to any number system, binary, octal, or hexadecimal, you will be using the division algorithm. Pag ano naman, any number system, binary, octal, hexadecimal to decimal number system, ang gagamitin mo naman is ang multiplication algorithm. So, if you are converting octal to binary or vice versa, you are going to use 3-bit substitution code. So, hexa to binary naman or vice versa, you are going to use 3-bit substitution code. Okay, kung octal to hexadecimal, gamitin mo first ang 3-bit substitution code, then convert it again to using 4-bit substitution code para sa hexadecimal. Then, hexadecimal to octal, gamitin mo first yung 4-bit substitution code and then 3-bit substitution code to get its octal equivalent. So yan yung lahat ng mga conversion techniques, no, na pwede natin magamit whenever we're going to convert one number system to another number system. So, by this time, it is now clear for us kung ano yung importance and uses ng mga number systems sa computer architectures. As well as, if maka-encounter tayo ng mga corresponding number system, such as binary, we can already understand kung ano yung equivalent niya in any number system. So, pwede natin siya i-convert to decimal kasi yun naman talaga yung default number system na ginagamit natin. So that's all for the discussion. Thank you for listening and watching. Good day.